That's tragic.
Okay, so where we're at in terms of the potential AP Physics memorial panel in front of the school. So after I deducted solar merge, which you all have got those, what you have left to get to the panel, and this is the collective that you all need to decide. It's like you want to have an AP Physics 2022-23 solar memorial panel. That's something that you all collectively need to decide. But that's what's left to get there. Now, the beauty of it is you guys have until May to get to that point. But,
How much?
120.
70?
120.
120. Yeah, no fault. So that's what's left. You can Venmo, you can do cash. I don't want your firstborn children. That won't get you anywhere.
Oh.
I know, sorry.
What about my second?
No, not even your second.
Second boards aren't worth it.
No. All right, so let's kind of go through this, kind of make sure everybody's cool with some of these answers.
That is true. Are you second board?
So
Are you second
on
board or first?
number 8,
I'm the only.
okay? Now, on number 8, pay attention that I'm asking for what it's going to weigh, which means I want an answer in what? Newtons. If I wanted mass, I'd ask for kilograms.
That's my bad.
Okay?
That's my bad.
So make sure your answers to number 8 are in newtons. Okay? Your first answer should be something times 10 to the third. Your second answer should be something times 10 to the second. Okay?
Yeah.
Now, on number 9, you want to find the mass of the air inside this room given these dimensions. That should be around 700 kilograms. Okay?
Yes, sir.
There you go.
Which one is that?
Yes.
Number
9. The mass.
That was strong.
700?
I am sure.
On number 10, and that's actually like numbers off of this, off the chairs. So you got a 20, supporting 25 kilograms, the area of the pad is 0.2 square centimeters. Remember, pressure is force per unit of area, okay? So on that one, on number 10, it's actually surprisingly large. It should be something times 10 to the 8th. Okay? Something times 10 to the 8th.
Let's go.
Your answer to number 11 should be something times 10 to the 5th. And the reason I asked that question, assuming the thickness is very small, what's the force acting on the bottom of the table? Because the reason I asked that is that it's a conceptual thing. Everybody has this idea that atmospheric pressure only acts down, okay? If atmospheric pressure only acted down, the tables would just collapse because you would have all the weight from the air pushing down just on the top of them, okay? There has to be an equalization of the pressure, okay? Otherwise, you would never be able to get out of bed in the morning. If atmospheric pressure was only acting down, you'd be like, oh, I can't get up, okay? It's a three-dimensional situation because it's created by these particles colliding. A lot of your answers on number 12, not all of them, but a lot of them, should start with 4s. Okay, so like for example, because if 12A is wrong, everything's going to be wrong. That answer to 12A should be around 450 kilograms. Devin, are we good?
Did you get that right?
Yeah,
Close, man.
I'm good.
You didn't say on the dot.
Yeah, I said around 450.
Yeah, I'm good.
Okay, all right. So what I'm looking for on number 13 is I'm basically kind of getting you through this process when something floats. So number 13, you got a bar of aluminum floating on a container of liquid mercury. And so it's just funny how things have changed. Like when I was in high school, my physics and chemistry teacher had like a baby food jar full of liquid mercury. And
What?
like when we would
Poison
get
it?
done with like labs or tests or something, he would just pour it out on the table, and it was cool because you could like bat it around. Okay, it was cool to watch, right? And now, like if you like, we can't even have liquid mercury thermometers in the school anymore because in case something breaks, they flip out. You got to call OSHA and hazmat and everything else. I'm going. When I was in high school, the teacher let us play with it. You know,
That's not good.
I don't know. It turned out okay.
No.
Did the
For most
teachers?
part, like a jar of it at my house.
The teacher's dead now.
Liquid
I actually just died about a month ago.
It's just straight up
Yeah.
liquid.
I
Jump
ate some of
gym
it.
time.
I ate some of it. It didn't do anything to me.
So
Some mercury.
on 13A, all I'm asking you to do is just come up with, on 13A, you could either do like density of the aluminum times the volume of the aluminum, whatever, okay? The whole idea being is that I just want you to realize that the buoyant force acting up has to equal the force of gravity pulling down. Okay, that's it. When something's floating, those are the only two forces that are in town. So, what you should get when you get to number 13E, and here's the whole idea, is that when that buoyant force equals the gravitational force, that's the density, because you're talking about the buoyant force. That's the density of the fluid times the volume of the fluid times G. Now, remember, that volume is what's submerged, okay? It's not the entire thing. It's just what's below the water line or below the liquid mercury line. And that's going to equal the mass of this case of the block times the volume of the block times G. Now, this is going to be the entire thing, okay, because you're trying to find the entire weight of the block. So this side over here is the entire mass of the block, just like this, and the entire volume of the block, not the part that's just submerged, okay, the entire block. So then what's going to happen is that your G's will cancel out. Then if you think this through, if something's going to float, okay, well, hold on, go away. That's actually density, not mass. That's density. So if something's going to float, then the density of the block has to be less than the density of the fluid. And then if you go over here, then if you take the volume that's submerged, that's the volume of the entire block. So because there's an equality sign, if you know the ratio of those densities, then you know the ratio of the volume that's submerged to the volume that's of the entire block. And so here's the ramifications of it. So like styrofoam, in terms of water, is really, really, really buoyant because styrofoam is not very dense at all. So if you have a chunk of styrofoam, very little of that is below the water line because of the fact that the density of styrofoam is so much less than the density of water. But this is actually like a pretty dense piece of wood. Like if you put this type of wood in water, it actually almost gets completely submerged. It's down to like almost like right here because this wood is so dense. Not dense enough to sink, but it's pretty close. So since this density is pretty close to that of water, it's just a little bit less, very little of that is actually below that, is above the water line. So if all goes well, that percentage on E should be something around your age. Okay? Something around your age. All your numeric answers on number 14 should start with a 1, and they should be something times 10 to the 5th.
On 14?
Yeah, on 14. Every answer should start with a 1, and they should all be something times 10 to the 5th. Any other questions? Good? Go.
Real quick, is 26 on the book problem? Would you want that positive or negative?
I don't care, it's just a difference, but make it positive.
Okay.
And that answer to 26 should be
Let's see.
a pretty small number, like less than 1. Okay? Anything else? Going once, going twice. So, okay, so this lab that you're going to do today is going to require a little bit of some precise measurement. And what you're basically going to do is you're going to look at two different blocks in two different fluids, okay? And I want to see how that gets affected. So here's the basic idea. It's going to be similar to what we did yesterday. So what you're going to do is you're going to measure the tension on the string using the Newton scales. So over here, you're going to have the depth in centimeters. So what you're going to do is you're going to take this block, okay, and you're going to have an iron block, and you're going to have an aluminum block. So the iron block, number one, is going to be more dense. Number two, the aluminum block is going to be bright and shiny. So that's how you can tell the difference between the two. So what you're going to do is you're going to take a ruler and you're going to make a mark at the 1.5 centimeter mark, okay? You can use a Sharpie, pencil, whatever, something that you can see. And then you're going to make another mark at the 3 centimeter mark, which is going to be pretty close to the top of this thing. So what you're going to do is that you're going to lower it down to that depth, and then you're going to measure how much tension there is on the string. Now, the other thing that you're going to need to calculate, and it will make sense later on, is that you need to calculate area GH, okay, which is a weird combination, but it's going to work, okay? So the area is going to be the cross-sectional area. G is your normal gravitational acceleration. H is going to be the depth that you lower it to, okay? Then you're going to do the same thing. Then you're going to lower it down to 3. You're going to measure the tension on the string, calculate that new value. So what you should see is that as you lower it down, what's going to happen to that tension that you're going to measure as you put it deeper and deeper into the water? Why?
Because the buoyant force increases.
Okay, so what you're going to get when you do this, like for example, when I did it, I got both, like on this first one is like 0.8 and 0.6, okay? So we're from 0.8 to 0.6. So what's going to happen is that you're going to draw these graphs. So the first thing that you want to do over here is this pre-lab, because that's going to help you out a lot. So here's the basic idea. You're going to draw a graph, and you're going to have tension here, and that tension is a measure of force, which means it's going to be in what? Newtons. Okay? Now, on the x-axis, okay, you're going to have the volume that's submerged. So let's talk about this. So what's that graph going to look like? So let's start at the beginning. If there's no volume submerged, is that going to be my maximum tension or my minimum tension? Max. So as my volume that's submerged increases, what's going to happen to the tension?
Go down.
It's going to go down. Okay? Start with that idea. Now, the tricky part is when you get to question number 2. Use dimensional analysis to determine the units of the slope. On the y-axis is tension, and the x-axis is AGH, where A is area, H is height. Okay? So this is going to get a little bit tricky in terms of dimensional analysis. So you have tension here, and down here you have AGH. So we're in the MKS system. So what does that area have to be in?
Meters
Meters squared. G is going to be in,
Meters per second squared.
and H has to be in
Meters.
So what you want to do is knowing that that tension is in newtons,
It's meters.
and what's another way to express newtons?
Meter, kilogram meters per second.
Kilograms meters per.
Second squared.
So what you want to look at is this. You're going to find the units of this slope. Change in y over change in x. So you want to go in and you want to substitute all of these units. If you do this right, and this is a process, this is a process. If you do this right, you should come up with a very recognizable unit for slope. It's going to start off completely jacked up, but it should simplify down to something pretty simple. Okay?
Okay.
Just saying.
What's
All right. Now, you've got these the second pre-lap, third pre-lap. If the graph you drew in number 1 was for water, what would happen to the slope of the line if the liquid is much more dense, such as liquid mercury? So in other words, if this was the slope of your line in water, what would the slope of that line be if you had it in mercury? Would it be less dense? Or excuse me, would it be less steep, more steep, or the exact same?
more steep?
That's what you have to figure out.
Oops.
Okay? That's what you have to figure out. And then when you get to number 4, it would happen to the slope of the line if it was less dense, and that's what you're going to do in the lab. You're going to use methyl alcohol. Okay? So that's what you want to think through.
We got mercury?
No, I'm not going to let you play with it.
No.
I don't want the hazmat team showing up to the
Come
school.
on.
Damn it.
We want the
Okay.
COVID team.
Now, when you do your graphs, so here's what you're going to do.
Poking on that mercury.
You're going to take this, like that's water. So you're going to make a mark, lower it down to 1.5 centimeters, read the tension in the stream. Lower it down to 3 centimeters, get the reading. Now, if you want to,
I asked.
you could also then just keep the water and then turn and burn and go straight to the aluminum.
Place.
Make the mark on the aluminum, 1.5, boom, there you go. Then, back there, I've got a jug of ethyl alcohol. So what you can do is you take that water, pour it out, then fill it up with ethyl alcohol. Now, if you used a Sharpie to make the marks on that ethyl alcohol will tend to dissolve the Sharpie. Okay? Ink, not so much. Certainly, it won't do pencil. So that's going to be the roll of the dice. But again, you're going to lower it down into the ethyl alcohol and get those data. So this is why you're going to have 4 sets of data. You're going to have iron and water, aluminum and iron. You're going to have iron and ethyl alcohol, aluminum and ethyl alcohol.
Screen's like messing up back
Keeps
there.
glitching.
It keeps just flashing.
No?
Yeah.
Oh.
Oh, there it goes.
Oh.
There you go.
Face it that way.
Hey, what's the score?
All right.
Don't even tell.
Don't.
Say it later, please.
If that opens one more time,
Yeah.
I want to see if it floats in hydrochloric acid.
Oh no. I don't
Let me
think
give
it
you a
works.
hint. It won't.
But it might.
It's
Okay.
2-0. That's really properly.
You're lying.
This
Would
is not.
it float in
No,
water?
it's in the name of science. I'm just seeing if it
Stop.
floats.
Yeah.
Float in water?
Don't
Open
tell
it,
him
open it.
later.
Ethyl alcohol?
Tell him later.
He's looking around. That's 2.
Well, I just
They're
saw
just,
it.
they're just torturing you.
Stop opening it, please.
Alright, keep it close.
Just on the back.
2-0.
0. That will be your score on the lab.
Oh
Wow.
no. Oh no.
Okay. Now, you have, here's going to be the problem with these slopes, is that you're only going to have like a limited number of points because you're only going to have 2 data points. So this is where it's going to be important that you draw a good line of best fit, okay?
Yes.
Make sure that you show me how you calculate the slope, because you're going to have a slope for the aluminum and water. You're going to have a slope for the iron and water. Then you're going to find the average slope of those 2, and then you're going to calculate the experimental error. At that point, you'll know what the experimental error is. Remember, your experimental error is your theoretical minus your experimental divided by your absolute value times 100, okay? Now, I tell you that the density of the alcohol, the accepted value for that density of that alcohol, use 700
92.
kilograms per cubic meter, which is much less dense than water's 1,000. Now, you have, here's your procedure. I basically tell you what to do here. You have questions 1 through 8 to answer. Do not answer these questions here. Okay?
No.
I was already playing on it.
That's why it's a preemptive thing. Okay? Do not answer these here. Answer these on another sheet of paper. So you're going to have graphs. You're going to have questions to answer. Much to do. All right. Go. Lab freely.
I'm confused. On the graph thing, I got kilograms over meters cubed. That's not familiar.
I think he was on a different.
Really?
What is that?
What's this unit?
This one.
Oh, is that density? Oh. That's not bad.
Yeah. It doesn't make any sense. Really?
Really?
I wasn't thinking.
Really?
You want to think that one through?